Now we are going to discuss about the question in signals and system from GATE 2009. So coming to the question, here given that f of s is one-sided Laplace transform of f of t, then the Laplace transform of integral 0 to t f of tau d tau is obtained as. Option A is given as s into f of s minus f of 0, B is given as f of s by s, and C is integral 0 to s f of tau d tau, and D is 1 by s of f of s minus f of 0. So here out of the options the B is correct. So we'll see how we'll get the B is the solution. So coming to the solution, given that the Laplace transform of f of t, unilateral Laplace transform of f of t is f of s, then we need integral 0 to t f of tau d tau value now. So here using the property of using the integration property of unilateral Laplace transform integral minus infinity to t f of tau d tau, by applying the Laplace transform, this is f of s by s plus 1 by s integral 0 to integral minus infinity to 0 f of tau d tau. So here we need the integration over 0 to t f of tau d tau, then we have the limits of tau from 0 to t now. So here by observing, we need the integral minus infinity to 0 f of tau d tau, then by considering this tau value from 0 to t, we can make this integral minus infinity to 0 f of tau d tau equals to 0, because we need only from 0 to t. The negative values of tau from minus infinity to 0 becomes equals to 0. Then we have the property from 0 to t f of tau d tau, by applying the Laplace transform, is equals to only f of s by s, and this term equals to 0 here. Then the total Laplace transform of integral 0 to t f of tau d tau is equals to f of s by s only. Then we'll get the answer B here, that is f of s by s.